part of our sequence that when we started with arithmetic progression AP, we went further to talk about the sum of AP. We did GP, the sum of GP, and now we're taking a very large part in that topic, which is the sum of infinity, represented by x infinity. Okay, in a GP, whose common ratio is between -1 and +1, meaning within that range. Maybe common ratio is minus half, 2, minus 1/4, minus 1/8, or thereabouts, provided the range is between -1 to +1. We refer, when we want to solve such infinity, we see them as infinity that tends towards and sums that tends towards infinity. So we say as the sum, when it approaches the infinite value, as n approaches infinity, the formula will be a all over 1 minus r. Now look at these two examples. I think this first one will be a bit longer. Let's start with the second one, which says the sum of an infinity of a GP is 4, 2, and 1. So they want us to find the sum of infinity of that GP that has this sequence. The first, now from the question, we say from the question, A is called the first term, and AR is called the second term. The first term we're given here is 4, and AR, second term we're given here, is 2. So it means if I use this second line, I will say AR is equals to 2, where my A is equals to 4, so I'll say 4R equals to 2. My R therefore will be 2 over 4, which is what? Half. Okay, so the sum of infinity, which is x infinity, is equals to a all over 1 minus r, which will give me, what is my a? 4 all over 1 minus half, which will give me 4 divided by half, which is taken as 4 times 2 over 1. The answer to this will be what? 8. QED. All right. Now let's look at the second question. The second question says the sum of infinity of a GP is 80, meaning that this is now question 1. This was question 2. I'll start out with question 1, which says sum of infinity is equals to 80. If the first term of the sequence is 20, meaning that if A, which is the first term, is 20, find the second term. So we know the relationship that sum of infinity has with A and R is as it is here. S infinity, sum of infinity, is equals to A all over 1 minus R, which implies that 80, sum of infinity, will be equals to 20 all over 1 minus R. Is that taken? So replicating, I will have replicating, because I have to replicate both sides before I cross multiply. So I will say 80 over 1 is equals to 20 all over 1 minus R. So what do I do now? I cross multiply. Cross multiply. If I cross multiply, I will have 80 into 1 minus R. Close my bracket, is equals to 20, because 20 times 1 is 20. Is that taken? So logically what it means therefore will be, I can now say 1 minus R is equals to 20 all over 80. That gives me, which is equal to 1 over 4. So my minus R will be, I move to, so 1 over 4 minus 1 over 4 minus 1 will give me minus 3 over 4. Therefore, if I multiply through by 1 or divide through by -1, I will have minus R all over -1 equals to minus 3 over 4 divided by minus 1. This will cancel out. So my R will be equals to 3 over 4. Now the question now says, the question says find the second term. It's a GP operation. So we know second term of a GP, the second term of a GP is AR, which is equal to, what is my A? My A is 20 times my R, 3 over 4. This cancel this, 5. My answer is 15. Second term is equal to 15. That brings us to the end of the sum of infinity. So I would give you the classwork, and so that by the time I want to solve, I'll give you the classwork in a jiffy. By the time I want to do the correction of this classwork, we'll now take them in our next slide. Okay, so hold on with me. Let me write the classwork for this sum of infinity so that we can have it too.